Hello, good morning everyone. Today we are going to solve Gujcet 2022 paper, and let's see how many questions are omitted from the paper and how many questions are right now in the syllabus. Okay, so let's start without wasting any time. Let's see what the first question says. An air-cooled solenoid with length 30 cm, area 25 cm square, number of turns 500, carries current of 2.5 ampere. The current is suddenly switched off in a brief time of 1 millisecond. How much is the average back EMF induced across the ends of the open switch in the circuit? Ignore the variation in magnetic field near the end of the solenoid. Okay, so for that we know that for the solenoid of here the case is about induced EMF, and induced EMF E is equals to minus L di by dt. See, here current is given I and t is 1 millisecond, and for L we know that L is equals to mu 0 n square A by L. Okay, so small l, mu 0 n square A by L. So minus mu 0 n square A divided by L into di by dt. Here if you see, by putting the value, see, negative sign says that it's back EMF, so we can neglect the negative sign. And mu 0 is equals to 4 pi into 10 to the power minus 7 multiplied by 500 square, because number of turn is 500, multiplied by 25 into 10 to the power minus 4, area of cross section, divide by length is 30 centimeter, so 30 into 10 to the power minus 2, and multiply. Last thing is current and time. Current is minus 2.5. if you see minus sign and minus n, because current is dropped, barabar. So 1 into 10 to the power minus 3, and here एक second, for convenience I will switch this to here. Okay, so here by solving this in calculations, see this negative sign is neglected, and our answer E is equals to 654166 into 10 to the power minus 6, which is almost equals to E is equals to 6.54 volt. So 6.54 is option A. Next question. For an ideal transformer, NS grid is greater than NP. See, if number of turn in second coil is greater than number of turn in primary coil, secondary coil is greater than, therefore that means that transformer is step up transformer, and for step up transformer we know that Vs is greater than Vp. So Vs is greater than Vp. Our answer will be B. Next question. A charged 10 microfarad capacitor is connected to a 16 millihenry inductor. What is the angular frequency of free oscillations of a circuit? So for free oscillations, omega is equals to 1 upon under root LC, and if we see 1 upon under root LC, L is equals to 16 into 10 to the power minus 3 multiplied by 10 microfarad, means 10 into 10 to the power minus 5, and if you solve this, 1 divided by 4 into 10 to the power minus 4, so answer will be 0.25 into 10 to the power 4 radian per second, which is equals to 2500 radian per second. 2500, option will be D. Next question. A light bulb is rated at 200 volt for a 220 volt supply. Find the resistance of the bulb. Okay, so for resistance we know that power is equals to V square by R, and R is equals to V square by P. means 220 square divided by 200. A little bit difficult question is asked here. 00 divided by 200. 242 ohm is your answer. Option C. Next question. A radio can turn into any station in the 6 MHz frequency to 12 MHz frequency band. What is the corresponding wavelength band? C is equals to 3 into 10 to the power 8 meter per second. Okay, another difficult question. C is equals to F lambda. We know that. And we have to find lambda. So lambda is equals to C by F. And for that, here if we consider, let's say lambda is equals to C 3 into 10 to the power 8 divided by 6 into 10 to the power megahertz means 6. So answer will be 3 divided 6 means 1 by 2 into 10 to the power 2. 1 by 2 is equals to 0.5. So 0.5 into 10 to the power 2 means 50 meter. In there this will be maximum, lambda maximum, but in here the given options it satisfies only for B, so we don't have to calculate for the another 12 Hz frequency. Now see what's next question says that a charged particle oscillates about its mean equilibrium position with a frequency of 10 to the power 9 Hz. What is the frequency of electromagnetic wave produced by the oscillator? Okay. See, in this question, oscillator frequency of electromagnetic wave, frequency of EM wave is equal to frequency of oscillator of charged particle. Frequency will never change, therefore answer will be B. Frequency is like fingerprint, we have discussed it so many times, and according to this our answer will be B. Let's see what 7 question says. A light from point source in air falls on a spherical glass surface of refractive index 1.5 and radius of curvature 20 cm. The distance of light source from the glass surface is 100 cm. Find the image. Okay, so here if we consider for a spherical glass surface, we know that minus n1 by u plus n2 by v is equals to n2 minus n1 divided by r, and n1 is air, so n1 is equals to 1 and n2 is equals to 1.5. we can also write as 3 by 2. So in our answer minus 1 by 100. See, here it's spherical glass surface and image is in the opposite direction from the glass source, so we can take as minus 100 plus 3 by 2 into v, because object is in opposite direction. Here somewhere object and here something image is formed, therefore next answer is 3 by 2 minus 1 divided by 20. So according to this, moving further, 3 by 2v is equals to 1 divided by 2 into 20 minus 100. 100 will be comes in this side, therefore 3 by 2v is equals to 5 by 2 divided by 200, taking LCM. Therefore v is equals to therefore 3 by 2v is equals to 3 by 200. So this 200 cuts and it will be 100 and 3 cut, therefore v is equals to 100 centimeter from convex surface. So our answer will be 100 because convex surface, answer will be positive. Now see what next question says. Double convex lens to be manufactured from a glass of refractive index 1.5 with both faces of the same radius of curvature. Radius is equal, means R1 is equals to R2 is equals to R. What is the radius of curvature is required for a focal length is to be 20 centimeter. So again the same formula, 1 divided by F is equals to N2 minus N1 divided by N1 into 1 upon R1 minus 1 upon R2. But here we know that R1 is equals to R and R2 is equals to minus R. Why? So both the surface are in same and opposite direction, so one is positive. Therefore we can write that 1 by 20 is equals to 1.5. Here I think it's 1.55. So 1.55 minus 1.100 divided by 1 into here what is happen 1 minus 1 by R, so it will be 2R. Therefore 1 by 20 is equals to 0.5 into 2 divided by R. So therefore R is equals to 2 into 20 into 0.55. The answer will be 1.1 multiplied by 20. So it will be 22 centimeter. So answer C. Moving further, what is the focal length of a convex lens of focal length 30 centimeter in contact with concave lens? Okay, so further here is one is convex lens and second one is concave lens. Let's see, it is concave lens and here it is convex lens, and we have to find the focal length of this portion. So for convex lens we know that focal length will be positive, so 30 centimeter, and for concave length focal length will be negative, so minus 10 centimeter. And when the lenses are in contact, equivalence is equals to 1 upon F1 plus 1 upon F2, like a parallel resistor. So answer will be 1 by 30 minus 1 by 10, so it will be 1 minus 3 by 30. The answer will be minus 15 centimeter. F is equals to A. C. An unpolarized light. Unpolarized light is incident on a plain glass surface. What should be the angle of incidence so that refracted and reflected rays are perpendicular to each other? See, this question is in omitted syllabus portion, but we can solve this. N of glass, we have to remember that N of glass, N is equals to 1.5 and tan theta is equals to N, so theta is equals to tan inverse 1.5. See, in your exams no scientific calculator will be allowed, but you will be provided logbook, and you have to see in logbook where is 1.500 and certified, and theta will be situated in 56 degree and 4 minutes. So here satisfies by two equations, 56 and 37, but here in this case they have to give refractive index of glass is actually 1.48, and if you see actually glass refractive index 1.48, the answer will be 56. So here answer is 56 degree. Next question. Two slits are made 3 mm apart and screen is placed 2 meters away. What is the fringe separation when blue-green light of wavelength 600 nanometer is used? Okay, so for blue-green light of 600 nanometer, we know that distance between two consecutive fringes, fringe, x is equals to lambda d by d. So lambda is 600 nanometer, means 600 into 10 to the power minus 9 multiplied by 2 millimeter d, capital D, and small d is 3 millimeter, so 3 into 10 to the power minus 2, this equals 2. Answer will be 2 to the 4, 4 into 10 to the power minus 4, means 0.4 mm. A. Next question, what says? Estimate the distance for which ray optic is good approximation for an aperture of 5 mm and wavelength is 500 nanometer. So this question is also comes in omitted syllabus portion because aperture is removed. But for aperture we know that ZL is equals to a square by lambda, and ZL is equals to a square means 5 into 10 to the power minus 3 whole square divided by lambda is 500 into 10 to the power minus 9. So it will be 1000 divided by 20, which means equals to 50 meter. So answer will be A. Let's see next question. What is de Broglie wavelength associated with an electron moving with a speed of 4.6 into 10 to the power 6 meter per second? Mass of electron and Planck's constant is given. We know that for de Broglie wavelength lambda is equals to h upon mv, and h is 6.63 into 10 to the power minus 34 divided by mass 9.11 into 10 to the power minus 31 multiplied by velocity 6.4 into 10 to the power 6. Question is easy, calculation is difficult. Lambda is equals to 0.11371 multiplied by 10 to the power 9. 1.113 means B, 114 ampere. Next question. An electron, alpha particle and proton having same mass kinetic energy, which of these have the shortest wavelength? We know that for shortest wavelength h is equals to 1 upon under root 2m e, means lambda is inversely proportional to root m. So whose mass is less, that wavelength will be maximum. So shortest wavelength is alpha particle. Alpha particle wavelength is minimum because alpha particle mass is maximum, 2He plus helium nucleus, and electron wavelength is maximum. So according to this you can say both the answer, and answer is A. Now let's see in the next question what it says. A difference of 1.5 electron volts separated two energy levels in an atom. What is the frequency of radiation emitted when the atom makes transition from upper level to lower level? Okay, transition of atoms. So for that energy is given is 5.4 eV, and for that we can say 5.4 multiplied by 1.6 into 10 to the power minus 19 electron volt, and E is equals to HV, and we have to find the frequency. So frequency V is equals to E by H, and E is equals to 5.4 into 1.6 multiplied by 1.19 10 to the power minus 19 multiplied by 6.25 into 10 to the power minus 34. So our answer will be 1.304 into 10 to the power 15. Okay, so A. Next question. What is the shortest wavelength present in Paschen series of a spectral line? See, if you see, this question is also in omitted portion, or either it could not be, because we have practiced so many times that 1 upon lambda is equals to 1 upon r into n1 square minus 1 upon n2 square, and for the shortest wavelength electron should be transit from infinite line. So 1 upon lambda is equals to r divided by 1 upon See, for Pastian, we see n is equals to 1, 2 and 3. It's Lyman, Balmer, Pastian, bracket and Fund. N is equals to 4 and n is equals to 5. So here we have n is equals to 3. So 3 square is 9. So therefore lambda is equals to 9 by r, and 9 divided by, let's say r is 1.0971700 into 10 to the power 7. So our answer will be 820 nanometer 0 D. See, in this question you have to go with maximum numbers of approximation because two answers in similar. So for that you have to go for more numbers of approximation. What's the next question says? The radius of innermost electron orbit of an hydrogen atom is 5.3 into 10 to the power minus 11 meter. What is the radii of n is equals to 3? Okay. So for n is equals to 3, we know that r is directly proportional to n square, and innermost orbit means r1 is equals to Bohr's orbit, and we know that for Bohr's orbit r1 is equals to 0.53 angstrom, which means 5.3 into 10 to the power minus 9 meter. So r3 by r1 divided by n3 by n1 square means r3 is equals to 3 3s are 9 multiplied by r1. So 9 into 5.3 multiplied by 10 to the power minus 9, and 5.3 is means 47 point something, 47 and 7 into 10 to the power minus 9. So answer will be 4.7 into 10 to the power. एक second, here I think I have done calculation mistake. Okay, so 0.53 means 10 to the power 11 meter. So this will be 10 to the power 11 and it will be 10 to the power minus 10 meter. So 4.7 into 10 to the power 10 B. Moving further, in accordance with Bohr's model, find quantum number that characterize the Earth revolution around the Sun in the orbit of radius 1.5 into 10 to the power 11 meter with orbital speed of 3 into 10 to the power 4 meter per second. Mass of Earth and h is given. So for Bohr's model and quantum number, we know that L is equals to nh upon 2 pi and L is equals to mvr equals to nh upon 2 pi. This question is for maths checking. N is equals to 2 pi divided by mvr upon h. Okay, so 2 second, I need more space for calculation. 2 multiplied by 3.14 multiplied by mass of Earth, which is 6 into 10 to the power 24 multiplied by V. V is 3 into 10 to the power 4 and R radius 1.5 into 10 to the power 11 divided by H. H is 6.625 into 10 to the power minus 34. On calculating this, our answer will be 25.59 multiplied by 10 to the power 73. Therefore answer will be 2.5 into 10 to the power 74. 2.5 C. N is equals to 74. It is 4. On moving further, let's see what next question is. Okay, given the following atomic mass number U, He and thorium, calculate the energy release in alpha particle, alpha decay. Okay, energy release in alpha decay. So for that we know that for urium 90 to 238, it goes under the process, and this is nuclear fission reaction where a bigger nucleus is break into two smaller nucleus. So thorium 90 and 234 plus 2He4 plus some amount of energy is released in this portion. Okay, so from that we can calculate that energy released in this portion is equals to mass of urium minus mass of thorium minus mass of helium nucleus multiplied by 931.5, and mass of urium is given 238.05079 minus 234.04363 minus 4.00206 and multiply by 931.5. Again, I think this is mathematics paper instead of physics paper. And answer will be 0.00456 multiplied by 931 MeV. 931 is equals to 4.2476 MeV. So it is equals to 4.5 MeV. 4.25, sorry. Answer will be A. And radioactive isotope has half-life T years. How long will it take the activity to reduce to 0.65? Okay. See, this question is in omitted syllabus because, this question is in omitted again. This question is in omitted syllabus because half-life is not in our syllabus. But if we see this question here, let's say total numbers of nucleons are n, and from n to 0.5 means half n, it will be take t times. Then from n to 0.25 it will take another t time. From t next t time it will reduce to 0.0125 times to n0, and from that t it will take 0.06. Here a second, I made a mistake. 0.1. 60, okay, to n0. So it will take total 1, 2, 3 and 4 t times. And if you see by formula, it will be n is equals to n0 upon 2 raised to n, where n is equals to time taken to reduce, or t n is equals to here. Okay, next question is another of half-life, but we see the half-life of 38 SR90 is 28 years. What is the distinguishing integration rate of 38 gram of this isotope? Okay, so for cesium we know that 90 gram is equals to 1 mole, and 1 mole is n Avogadro number, n. So 38 gram is equals to, let's say it is x number, and for this radioactivity we know that R is equals to n lambda, and lambda is equals to 0.693 divided by tau 1 by 2. So where n is equals to, n is, let's say this is n, so n is equals to 38, n say, or we can say x is equals to 38 by 90 into n, a, which is Avogadro number. On putting this value in this equation, 38 by 90 into 0.022 into 10 to the power 22 multiplied by 0.693 divide by total time is 28 year. In 28 year 365 days multiplied by 24 hour multiplied by 3600 seconds. Again next paper. Okay, so r is equals to 2 multiplied by 10 to the power 14. Here answer is in approximation and we can take to A. Next question. Okay, another omitted syllabus question, but see, the circuit shown in figure works as which gate? Okay, here for that answer, let's say we apply input A and B, so it will be A bar and B bar, and here it is NOR gate. So for NOR gate, A bar plus B bar and whole raised to bar, and if we know the equation, it will be A dot B, and A dot B is AND gate, so answer will be C. So many omitted syllabus questions. On moving further to the next question, which is when forward bias is applied to PN junction diode, what happen? अगर PN junction diode को forward bias में कनेक्ट करते हैं तो શું થશે? તો કે લોઅર ધ પોટેન્શિયલ બેરિયરની વિથ છે તે ઘટી જશે. ચાલો નેક્સ્ટ ક્વેશ્ચન શું કહે છે? સપોઝ અ પ્યોર સિલિકોન ક્રિસ્ટલ હેઝ 5 into 10 to the power 28 numbers of atoms per meter cube. It is doped by 1 ppm concentration of pentavalent impurities, pentavalent arsenic. Calculate the numbers of electron and hole. Okay, so for Ne we know that it is 5 into 10 to the power 28 into in total 1 millimeter cube, so multiply by 1 meter cube and divide by 6, it is 1 part per million, so answer will be 5 into 10 to the power 22. But on moving further, we know that Ni square is equals to Ne into Nh, so Ne into Nh, therefore Nh is equals to Ni square divided by Ne. This question was asked in 2025 paper also, but at that paper there is only number density is asked. Here we have to find numbers of electron and hole. So number of electron and hole is equals to, according to calculation, 1.5 multiplied by 2 into 10 to the power 16 square divide by 5 into 10 to the power 22. So answer will be 4.5 into 10 to the power 9 per meter cube. So B answer. Next question. Dimensional formula of electric flux. Dimensional formula for electric flux. We know that for flux 5 is equals to E into A, and E is equals to force per unit charge into A, and force is M1 L1 T minus 2 divided by A1 T1, and A is area L2, so answer will be M1 L3 T minus 3 A minus 1 L3 T minus 3. Okay, C 1 L3 T minus 3 A minus 3. Okay, next question. An electric dipole with dipole moment 4 into 10 to the power minus 9 centimeter is aligned at 60 degree with the direction of uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. Calculate the magnetic of torque acting on it. Okay, so for dipole we know that torque is equals to P E sin theta, and P is given 4 into 10 to the power minus 9, E electric field 5 into 10 to the power 4, and sin 60. So 2 into 10 to the power minus 4 multiplied by root 3 by 2, so answer will be 1.73 into 10 to the power minus 4 Newton meter. Okay, 1.4 into, okay, here I think two answer will be there, A and B, because if we say 17.3 into 10 to the power minus 5 Newton per meter also there, so A and B both is true. Moving further in the next paper, an infinite line charge produces an electric field of 9 into 10 to the power 4 Newton per coulomb at distance of 2 cm. Calculate the electric field produced at distance of 3 cm. So we know that infinite line charge is equals to, electric field for infinite line charge is equals to 2k lambda by r, and if lambda is asked, it will be 2r by 2k. So it will be 9 into 10 to the power 4 multiplied by 2 into 10 to the power minus 2 divided by 2 multiplied by 9 into 10 to the power 9. Both this cut, this also cut. It will be k value is misplaced now. it's 4 and 6 and 2, so it will be 10 to the power minus 7 coulomb per meter. This will be level, but we have to calculate electric field at 3 cm distance. So E dash is equals to 2k lambda by r dash. So for that 2 into 10 to the power, let's write this solution in another, so we cannot be confused. 2 multiplied by 9 into 10 to the power 9 multiplied by 10 to the power minus 7 divided by 3 centimeters, so 3 into 10 to the power minus 2. So it cut 3. Answer will be 6 into 10 to the power 4 Newton per coulomb. Yeah. Question number 28. How will you connect 4 capacitors, each of 4 microfarad, having equivalent resistance of 1.6 farad? Okay, 1.6 farad. So here, if we take all the 4 capacitors in series, then our answer will be 1 microfarad. So this option will not be there. And if we take all the 4 in parallel, so then also our answer will be 16. So this also not be considered. If we say 2 capacitors are parallel, so let's say 2 are in parallel and 2 are in series here. So 4 and 4. So equivalence capacitance of this 2 is 8 and this 2 is 2. So C is equals to 2 into 8 divided by 2 plus 8. So it will be 16 divided by 10. So answer is equals to 1.6 microfarad, and we have to find 1.6. So answer is A. Okay. A slab of material of dielectric constant 3 has the same area as the plate of parallel plate capacitor, but the thickness is 3/4. It is the separation of plates, where D is the separation of plate. What is the electric potential difference between the plate when the slab is inserted between plates? Actually, this question is of textbook exercise illustrations, last illustration, but we will solve V is equals to V1 plus V2 in this case, and V1 is equals to E0 by D into 4. Why? Because let's say total separation of plate is D, and till 3/4 it is dielectric constant, and half D/4 there is nothing, so it is D/4 plus E by K, not K by E by K into 3/4. So answer will be 0 by D into 4 plus K into 3D by 4. But here dielectric constant 3 is given, so K will be 3, so this 3 will be cut, and E0 by D into 2, which is equals to V by 2, initial V by 2. So answer is C. Next paper. The molecule of substance has permanent electric dipole moment of magnitude 10 to the power 29 centimeter. 2 mole of substance is polarized at low temperature by applying the strong magnetic field of magnitude 10 to the power 6 volt per meter. What should be the potential energy of it? So for potential energy, we know that here dipole moment of 2 atom or 2 mole, P is equals to 2 into 6 into 10 to the power, not 2 atom, 2 mole into 10 to the power minus 29. So dipole moment will be 12 into 10 to the power 6 coulomb per meter. And potential energy U is equals to minus PE cos theta, and theta is 0 degree because it is in the direction of electric field. So answer will be minus 12 into 10 to the power minus 6 multiplied by 10 to the power 6 into cos 0, and cos 0 is 1. So answer will be minus 12 joule. B. Next question. Question 31. At room temperature 27 degrees Celsius, the resistance of a heating element is 100 ohm. What is the temperature of element if resistance is found to be 137 ohm, given that the temperature coefficient of material of resistance is 1.5 into 10 to the power minus 34 per degree Celsius? Okay. So for that we know that R theta is equals to R0 into bracket 1 plus alpha into theta minus theta 0, and we have to find theta 0, theta, which is equals to R theta minus R0 divided by R0 into alpha upon plus theta 0. On putting value 137 minus 100 divided by 100 into 1.3 into 35 into 10 to the power minus 4 degrees Celsius plus 27. So answer is 37 into 10 to the power 2 divided by 1.535 plus 27. Okay. And on moving solving this further, answer will be 237 plus 27 is equals to 2767 degrees Celsius. 2767. Move this whole portion aside, need some space for next question. For the given flowing circuit diagram dissipated the electrical power of 150 ohm, then find the value of resistance R. Okay, here power is given and we know that power of parallel P1 plus P2. I think this portion is emitted but not sure, so we solve this as an include syllabus question. And for power is given power is how much? 150 volt, and P is equals to V square by R1 and V square by R2. So for example, V is 15, so answer will be 150 divided by 225 is equals to 1 upon R plus 1 divided by 2. So therefore R 2 by 3 multiplied by 1 by 2 is equals to R. Therefore R is equals to 6 ohm. 6 ohm. C answer. Next question. The number density of free electron in a copper conductor estimated 8.5 into 10 to the power 28. How long does an electron take to drift from one end of wire 6 meter long to its another end? Area of cross section is 1 into 10 to the power minus 6 meter square and it is carrying current 1.5. Okay, so for this we know that I is equals to NAVD into E. NAVD and VD is equals to I by T. L by T. So therefore I is equals to NaLe by T. So therefore T is equals to NaL into E by I. And now we have to put only values in this question. 8.5 into 10 to the power 20, 8.5 into 10 to the power 28 multiplied by A. A is given 10 to the power minus 6 multiplied by 6 into 1.6 into 10 to the power minus 19 charge of electron divided by 1.5. So our answer is 54.4 into 10 to the power 3, which is 5.4 into 10 to the power 4 seconds. So 5.4 into 10 to the power 4, B answer, C. Next, a solenoid of length 2.5 and radius 1 centimeter is made up of 500 ton. It's carrying current of 2.5 ampere. What is the magnitude of magnetic field inside the solenoid? Magnitude of magnetic field inside the solenoid, B is equals to mu 0 n into I. Therefore n, for n we know that it is capital N by L, it is small n, mu 0 n, and we know that n is equals to n by L. So mu 0 into n I by L. So answer is equals to 4 pi into 10 to the power minus 7 multiplied by n. N is 500. I is 2.5 divided by total length. Total length is 2.5. So our answer is 62800 into 10 to the power minus 7. So answer is equals to 6.2 into 10 to the power minus 3 Tesla. 6.2 into 10 to the power minus 3A. Okay. Next question. How does shunt wire should be? Shunt wire should be, we know that for shunt wire R is equals to rho L by A, and according to this the wire should be short and wire should be short and thick for the shunt wire, because as the area increases resistance decreases, and the length should be minimum. So R is equals to, answer is D. Next question. Two long and parallel straight wire A and B carrying current of 10 ampere and 4 ampere in the same direction are separated by a distance of 2 cm. Estimated the force of them is 4 cm on the section A wire. Okay. So for the force we know that F is equals to mu 0 I1 I2 L upon 2 pi y. And for these force between two wire, 4 pi into 10 to the power minus 7 multiplied by 10 multiplied by 4 into 10 to the power minus 2, because it is 4 centimeters, and divided by 2 pi y. So 2 pi into 2 into 10 to the power minus 2. So this cancel, this 4 pi are cancel. So answer is 16 pi. Answer is 16 into 10 to the power minus 6 Newton. So is equals to 1.6 into 10 to the power minus 5 Newton. 1.6, I think this is 1.5. B. Next question. A solenoid has a core material with a relative permeability 400. The winding of solenoids are insulated from the core and carrying current 1 ampere. The number of turn is 1000 per meter. Find the magnetic field. So for that we know that B is equals to mu 0 mu R into Ni, and mu 0 is equals to 4 pi into 10 to the power minus 7 multiplied by 400 multiplied by 1000 multiplied by 1 ampere. So answer is 16 pi into 10 to the power minus 2. 16 pi is B. 16 pi into 10 to the power minus 2, C. A A short bar magnet is placed at axis of 30 degree with a uniform external magnetic field of 0.25 Tesla. Experiences torque on magnitude of equals to 4.5 into 10 to the power minus 2 joule. What is the magnitude of magnetic moment of the magnet? So for that we know that torque is equals to mb sine theta, and we have to find m is equals to torque upon b sine theta. So for that, torque upon b sine theta is equal, torque is given 4.5 into 10 to the power minus 2 divided by b 0.25 multiply by sine 30 1 by 2, so 1 and 2 here. So according to this our answer will be 36 into 10 to the power minus 2. So answer will be 0.36 joule per Tesla. So 0.36 joule per Tesla A. Barabar. Moving further in next question. The polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic field. Magnetic flux is said by length. A pair of adjacent coil has mutual inductance 1.5 Henry. If the coil in one coil changes from 0 to 0.5 ampere, current in one coil changes from 0.10 to 10 ampere in 0.5 seconds. What is the change of flux linkage with the other coil? Okay. So we know that for mutual inductance 5 d phi by dt, d phi by I, change in flux. So we have to find delta flux is equals to m into I, and mutual inductance is given 1.5 into current is given 0.5 and 10 seconds is 50. So it will be 150 is 1.5 Weber. 115 C answer. So this was the paper of Gujcet 2023. Please tell if there is any mistake in the solution or give your suggestion in the comment box. Thank you.